Good morning, students. Today's new topic in the subject of physics O levels is fission in the topic of radioactivity. So concentrate yourself. This is important topic. So nuclear fission. When the nuclides of uranium-235 are bombarded by slow thermal neutrons, any of the nuclides is capable of capturing a neutron, resulting in a breaking up, that is called fission, in the following manner as shown below. And here is the process. This is the uranium-235 atom nuclide that is bombarded by the neutron that is actually capable of capturing the neutron, resulting in the breaking up of the uranium nuclide in this manner. The products of the fission of one uranium-235 nucleus are, and here are the products. When this process occurs, two new elements of approximately equal mass, known as fission products. A pair of the examples is barium and krypton. So almost equal masses of two elements are produced in the process. Number two or three fast-moving neutrons are also produced. In this process, 3 neutrons are produced. In some cases, 2 neutrons are produced. And number 3, about 3 multiplied by 10 raised to power minus 11 joule of the energy. This energy is released as radiation and as kinetic energy of the neutrons. This kinetic energy is the source of the heat energy obtained from a nuclear reactor. So this is the third product of the fission process. And here is the equation. When uranium-235 nuclide is bombarded by a neutron, barium and plutonium is produced. These are almost of equal masses, and 2 neutrons are also produced. The total mass of the daughter nuclide, these products are called daughter nuclide, and this is parent nuclide. The total mass of the daughter nuclides and that of the 3 neutrons is less than the total mass of the bombarding neutron and that of the parent nuclide. So this loss in mass or decrease in mass is called mass defect, given by the symbol delta M, using Einstein mass energy equations. So the thing is, the total mass of this neutron and the parent nuclide is more than the mass of the daughter nuclide and these neutrons, because the loss in the energy or mass, loss in the mass is actually represented by mass defect, represented by delta M, and this is represented by Einstein mass energy equation. Mass energy equation is delta E is equal to delta M into C square. So E is equal to mc square, where delta M is the mass defect, that is mass decrease in kilograms. C is 3 multiplied by 10 raised to power 8 meter per second is the velocity of the light, and E is the energy produced in joules, mainly heat. So these are the things. So E is the energy, M is the mass defect, and C is the velocity of the light. So the questions of mass energy equations are, these are very frequent questions which come in the paper, so concentrate yourself. Calculate the energy produced in the nuclear reactor if the nuclear reaction resulted in a decrease in mass of 20 grams. So this is the mass defect that is represented by delta M. So equation is delta E is equal to delta M into C square. Delta M is given 20 grams. So first we will convert this grams into kilogram by dividing 1000. So 20 divided by 1000 will be equal to 0.02. C's value is 3 multiplied by 10 raised to power 8, that is put here in the formula. You solve it on the calculator, you will get the answer, energy in joules. And other question is here, that is, calculate the increase in mass when 4200 joule of the heat is absorbed by 1 kg of the water to cause a temperature rise of 1 Kelvin. So increase in the mass is 4200 joule. Equation used is delta E is equal to delta M into C square. So delta M is the requirement, because calculate the increase in the mass is the requirement. So delta M will remain here. C square will come to the denominator of delta E. So delta E is given 4200 joule over C's value is 3 multiplied by 10 raised to power 8. Square is remain here. Solve it on the calculator. You will get the answer. Unit will be kg. Next topic in the lecture is uncontrolled and controlled nuclear fission. The 3 neutrons produced in the above nuclear fission can, if they are not controlled, continue to bombard 3 outer uranium-235 nuclides, each giving 3 further neutrons, resulting in 9 neutrons, and the reaction goes on and on, producing a nuclear chain reaction as shown below. So this is the figure that is showing uncontrolled fission process. 1 neutron is produced, 3 are further produced. So 1 is bombarded on the nuclide of the uranium-35, 3 neutrons are produced. Each one is further striking the other uranium-235 nuclide. So through this, further 3 are produced, through this, further 3 are produced, and through this, further 3 are produced. So in the beginning, there was 1 producing 3. These 3 are producing 9, and this process will be multiplied. This kind of the reaction is called nuclear chain reaction, and this is uncontrolled. An example of an uncontrolled nuclear fission occurred in the atomic bombs dropped by the Americans in Hiroshima and Nagasaki in Japan in 1935. That was a big disaster. However, controlling nuclear fission is one of the physicists' many challenges in life. They have done this in nuclear reactors, a diagram of which is shown below. So controlled fission process is carried out in nuclear reactors, and here is a diagram. These are called controlling rods. This is hot water out, this is cool water in. Here are steel pressure vessels, here are nuclear fuel in the core. So the process in the nuclear reactor is the boron rods can be pushed into or pulled out of the uranium metal housed in carbon blocks. When the boron control rods are pushed in, they absorb 2 out of 3 neutrons produced by each nuclear reaction. So this is the function of the boron rods. They pushed in and pushed out. Each time they pushed in, they absorb 2 out of the 3 neutrons produced. So there will be only 1 left. So that will strike and will produce again 3. So boron rod will push again and will absorb 2 out of 3 neutrons. So again 1 will be left. So this kind of the fission process which is carried out in nuclear reactor is called controlled fission. These control rods called moderators allow nuclear fission to proceed at a controlled rate. The energy produced is usually in the form of the heat evolved. The carbon dioxide gas is then heated to a very high temperature and channeled to heat water and turn the latter into steam. The steam then drives the turbines of the huge generators to produce electrical energy in the form of the alternating current. And this is the total process of the controlled fission. This is nuclear reactor. These are controlled rods. So I have told you earlier how fission process is controlled. So water is warmed, that is then converted into steam. Steam rotates the fans of the turbine. Turbine generates electricity. Electricity is sent then through the transformers to the grid station. And this is the flow diagram. Nuclear energy, heat in coolant, potential energy of the steam, kinetic energy of the turbine, and electrical energy is produced. So students, this was the topic of the fission. Read it again very carefully and make your notes. Thank you so much.